All right, we're going to look at alkynes and aromatics. And alkynes are first. Okay, alkynes are hydrocarbons with one or more carbon-carbon triple bonds. So we have alkanes, which are single bonds, alkenes, which are doubles, and alkynes, which are triples. Okay, we have acetylene. All right, is the simplest alkyne. You have a triple bond there between two carbons and hydrogens on the end. You'll have oxyacetylene, which is something that has that acetylene in it, in that triple bond. Okay, along those same lines, alkenes are very, very reactive molecules and are not as widely distributed in nature. There's not as many alkynes just out there, okay, as there are very, very many alkanes or single bonds because they're way less reactive. Okay, so that's kind of what they are in general. We're looking at triple bonds here. All right, when I name these, okay, they're named the same way as alkenes. We have the suffix YNE now instead of ENE. All right, and your long chain of carbons has to have the triple bond in it. Whichever way I can get that triple bond in, that is my longest chain. It's kind of like I was talking about where they're more and less important. Triple bonds are kind of like the most important of these versus singles and doubles. So even though I might be able to make a longer chain with a single bond or all single bonds, you have to go with the longest chain that includes a triple bond. All right, so let's name these two compounds here. All right, so I have to include the triple or the double bond. And let's look at the triple one first. And actually, that should be a triple right there. So let's look at this one on the left first, okay? So here I've got a triple bond and a double bond. This one's kind of easy in the sense that we have just one long chain. All right, so there's nothing weird I have to look at here. It's kind of just how these endings go. All right, so for this one, all right, I have to look at my longest chain. And if I count there, I have 1, 2, 3, 4, 5 carbons, and it includes both the triple and the double. That's good. So we're looking at pent. Okay, so some kind of pentane, okay, or pentene or pentyne. I've got pent, there's 5. Okay, this one's really weird because I have a double and a triple. Okay, the double is an ene, and the triple is an yne. The triple gets the higher precedence, which means this is my number 1 carbon here on the right, and then the triple bond follows that. So I have a triple bond on carbon number 1, and a double bond on carbon number, if I count, 1, 2, 3, carbon number 3. So what we do is we do pent, and then you do 3, En, go put the E on the end there. Okay, just En, no Ene, because the ending E is the end, okay? So pent 3-ene, you can do 1 yne. That's showing me that I have a triple bond on 1 and a double bond on 3, okay? Let's go ahead and look at this next one. Let's see how we can get our longest chain here. I have to include this triple bond here. So I'm going to have 1, 2, if I go straight across, 2, 3, 4, 5, 6. If I go this way, 1, 2, 3, 4, 5, 6. So it doesn't matter either way which way we're going to go here. I'm still going to have 6. All right. So I'm going to have hex. All right. My triple bond, I'm going to give it the higher importance. So it's going to be number 1. So I'm going to have 1 YNE. Okay. You don't have to put the 1 in there if you don't want to. In all reality, you can just take both of these ones out in both those problems. I kind of assumed if you don't have them in there, but it doesn't matter either way. All right, I also have that. If I go across, okay, since it doesn't matter, I'm going to have a group of 3 carbons here, and that's going to be prop. So I've got propyl. I want to know where is that propyl. That propyl group is on carbon number 3. So 3-propyl hexyne. You can do 1 hexyne if you want to. You can do hex 1-yne. So I could change this actually and do 1 hexyne like that, and that would work. You can put it in the middle, either way. So 3-propyl, 1 hexyne. All right, so now I want you to go ahead and try and draw the structure for 4-methyl-2-pentyne. And you should get a structure that looks something like this. All right, I got my triple bond here on 2, so there are 1, 2, and 3 on the 4th one. I have the methyl group. Always make sure that when you count, it's after that 2. So 2 and then the triple bond. All right, now we're going to look at aromatics. Okay, aromatic structures are related to benzene. That's the important part here. We're dealing with something with benzene rings and C6H6. They are called this because they have an aroma. Okay, they were originally identified by their aroma or their odor. So lots of these have common names that don't seem to make any sense with anything else. Like benzene, it's actually a common type name, but everybody calls it that, so that's what we call these. Okay. So some examples there down the bottom. We have benzene, naphthalene, anthracene, and toluene. And toluene is the one here with the little CH3 on top. So notice how we have these C6H6. Okay, they're all rings. Okay, we have 6 hydrogens because you can only have 4 bonds. So at this vertice right here, this is a carbon. All right, and I only have 4 bonds. So I have a double bond here for 2, another single for 3. So I'm only going to have 1 more H. So we just don't write those H's, but at each one of these spots you have an H, and that's where you get the 6 H's from. So each carbon has an H attached to it because that would be the 4th bond. You will often see benzene rings written kind of like this, all right, kind of like the nut for a bolt, all right, because these double bonds actually move around. If we talk about resonance structures, okay, they kind of all share all 3 double bonds, so that's why you get the kind of circle in the center because they're all kind of sharing everything. So these are benzene rings, okay, and they're, again, ones that smell. Okay, now we have a couple more examples, all right, that you need to write here. We have chlorobenzene, ethylbenzene, and 2-phenylbutane. Okay, these first 2 just have substituents off of the benzene ring. Okay, the second one actually has a substituent of a main chain. So this one you could kind of give this one 2 different names. Okay, call it 2-phenylbutane. Phenyl is what we call a benzene ring when it's off of a different chain. So you could call it 2-phenylbutane. You could also look at it as something with benzene. So if I called it something with benzene, you would have to look at what this group was. And this is 4, so looking at butyl. Okay, this carbon right here is connected to 2 other carbons in that chain. So you could also call it sec-butyl. So if I say sec-butylbenzene, that means I have a sec-butane group off of my benzene ring. So kind of either one of those names, but you do need to know that phenyl means that it is a benzene ring off of a main chain. Okay, the last thing we're going to look at here is if you have 2 nitro, and a different example that I used to use, I use bromine. So 2 bromo groups are added. You have 3 possible isomers, all right? And isomers mean, again, just different ways to look at the same formula, okay? So if we have dibromobenzene, you can have ortho, meta, or para instead of numbers. So with these 3 examples here that you have, I can have 1,2-dibromobenzene, or we can call that ortho. So if they're right next to one another, we call that ortho. If they're kind of one apart, that's called meta, and if they're exactly opposite, that's called para. So either the numbers or the actual kind of phrases in front. So ortho, meta, para, and those only work for benzene rings. We really don't use those prefixes for anything other than a benzene ring.